we're going to talk about ionic bonding in this section. So first thing I want to mention is that when you have atoms losing or gaining electrons to form an ionic compound, they acquire the noble gas configuration, but you need to recognize that they are not simply converted to a noble gas, and that's because the number of protons will not change. And therefore, if that doesn't change, then there's no way that the atom that forms the ions becomes a noble gas as a result. All it means is that it has the same electronic configuration as that of the nearest group 8 element. Now, when you have the two ions formed as a result of the transfer of electrons, then the resulting two ions, they're called an ion pair, and you're going to have a very strong attractive force between them because they're oppositely charged. And that strong attraction is called the ionic bond. And what you'll notice is that as a result of that attraction, there'll be basically an ordered arrangement assumed by the compound of different ions, because remember, there are billions of ions present and they will assemble themselves into a very ordered array, and that highly ordered collection of ions is called an ionic crystal. So the next slide is showing you basically what happens in the case of sodium chloride. So if you take a small piece of sodium and drop it into a flask filled with chlorine gas, then you're going to have a very exothermic, very violent reaction that generates a lot of heat and light. So that's the reaction that is being shown here in this picture. And this is basically showing you what happens as far as the atoms are concerned that are involved in this reaction. So in the case of sodium, it will lose its valence electrons, and those electrons will be transferred to the chlorine atoms of the chlorine molecule, and the result will be the formation of sodium chlorides. And then what you'll find is that billions of these ions will assemble themselves into an ordered array as shown here. So this is basically the arrangement that the sodium chloride will assume if you look at the gross structure of this compound, all right? So we call this a crystal structure. And this is what happens in the case of pretty much all ionic compounds, all right? Okay, so let me just skip all this here and talk about how we use Lewis symbols to represent what is happening in ionic bonding. So Lewis symbols can be used to represent ionic bonding between metals and certain, well, between nonmetals and certain metals. Namely, all the elements of the S block region of the periodic table, some of the P block elements, and very few of the D block elements, all right? So this is basically what happens in the case of sodium chloride, right? Which we saw earlier. So the sodium has one valence electron, the chlorine has 7. So what's going to happen is that the sodium will transfer its valence electron to the chlorine. The chlorine will now end up with 8 electrons on its outer shell, and the sodium ion will have 8 electrons on the outermost shell after the electron has gone. So therefore it's not shown here because those 8 electrons were previously the core electrons in the original sodium atom, all right? So that's what happens in the case of sodium chloride. And this is basically what happens in the formation of ionic compounds between nonmetals reacting with metals. So let's look at this example. This question is asking for you to use Lewis symbols to show the formation of ionic bonds between the magnesium and the nitrogen atoms. And the question is also asking what are the name and formula of the compound that results. So what I've drawn here are the different Lewis symbols for magnesium and nitrogen. As you'll notice, magnesium belonging to group 2A will have 2 electrons on its outer shell, and nitrogen belonging to group 5A will have 5 electrons on each of their atoms in the valence shell. So what will happen is you're going to have the transfer of electrons. Now, in order for this to be successful, you're going to need 6 magnesium atoms and 2 nitrogen atoms, because the total number of electrons being transferred will be 6, all right? So these 2 electrons will be transferred to this nitrogen atom, 1 electron will be transferred to this nitrogen atom, 1 electron here will be transferred to the other nitrogen atom, and these 2 electrons here will be transferred to the same nitrogen atom here. So the result of those electron transfers will be that you're going to end up with 3 magnesium ions and 2 nitride ions, and therefore the formula for the compound would be Mg3N2, and the name of the compound would be magnesium nitride. All right, so that basically shows you how we can use Lewis symbols to show the formation of ionic compounds from their constituent atoms. All right, we're going going to stop here because we're going to look at the formation of ionic compounds in more detail in the next chapter. So in the next chapter, or the next session I should say, we're going to look at the different types of energy changes that will occur as you go from the elements themselves to the final ionic compound formation. All right? Until next time.